Alright, so this lesson is looking at joint probability, also known as combined probability. In this situation, we're going to use AND or statements for combined events. Basically means, something along the idea of let's flip two coins and see what the odds of getting a certain outcome are. Or we could look at flipping a coin and rolling a six-sided die, or picking marbles out of a bag, or pretty much anything else like that. And we'll notice that the behavior of these are very, very strongly determined by using the phrases AND or the phrase OR. So let's take a look. Alright, so our concept. When we consider the probability of two or more events happening, finding that probability can be a little bit more difficult. When we look at our example, flipping a coin, whether it lands on heads or tails, but let's say we also needed to draw the four of spades. Well, we could look at that, or we could look at something like flipping a coin or drawing the four of spades. One of them is a lot easier, one of them is a lot more difficult. So, let's take a look at the probability of both events happening. That means that these things pretty much have to happen in the same instance. So I'm not going to flip a coin until I get heads and then try drawing the card. I'm going to say, you got one shot, you got to do both items, and they both have to be these exact specific things. So let's look at our example. We are flipping a coin and landing heads, and drawing the seven of diamonds from the deck of cards. So what do you think? Is this going to be more difficult or less difficult than winning one of these separately? We know flipping a coin is 50-50, or 50%, also known as one half. And drawing the seven of diamonds, well, that's 1 out of 52 cards in the deck, so it's 1 out of 52. It's very close to 2%. So we're going to look at this, and we're going to see whether or not doing those together could change the odds. Alright, so the first thing, let's look at the coin. It's one half probability. It's also 50% of the time that we win. It seems just as easy to win than it is to lose, so we should expect to get heads about half of the time. The other times we'll get the tails. And we'll use a number just to kind of conceptualize it. Out of 100 trials, we should get about 50 wins and 50 losses. The thing is, we're not guaranteed to get 50 wins and 50 losses. Technically, we could flip a coin 100 times, and every single time it could land up heads. Is that going to happen? Most likely not, because that's a really, really difficult thing to do. And we'll look at how that plays a role in this. Alright, the next thing we have is a deck of cards. We're going to choose the seven of diamonds as our winning outcome. So 1 out of 52 probability, it's about 2% of the time we'll win. It's a pretty difficult thing to do. Shuffle a deck of cards and then pick up the top card. Is it the seven of diamonds? Most likely it's not going to be. About every 52 games that we play, we should expect to win once of them. So, out of the 52, 1 win and 51 losses. But now we start to think about, what if we won both of them? Let's take a look at how we can win both events at the same time. The coin, remember, is at 50%. The deck of cards is very close to 2%. Let's use some logic. Alright, so, if, and it's a huge if, we draw the seven of diamonds, we just accomplished the task with the odds of 1 out of 52. Now, we also have to win with the coin, so we should win with that half the time. You could pull that miracle and pull the seven of diamonds, but you also got to win that coin flip. If we win with the deck of cards twice, we should also expect to win the coin only once. So let's say of the 52 cards that we've pulled over, first card is a seven of diamonds, awesome, we won. So we flip the coin, and maybe we got unlucky, it landed on tails, or maybe it did land on heads. So what our real odds translate to is, out of every 104 games, we should win roughly once. And the reason I chose 104 is because it's 52 cards. We'll double it to 104, just so we can have two instances, because of one of those instances, we might get heads. Of the other instance, we might get tails. And that's just, what should be expected to happen. This is not guaranteed either. This is just, kind of playing the odds in our head, the theoretical odds, not the empirical. Because once you do an experiment, things can go pretty much anyway. Alright, let's take a look at this. Let's take a look at the coin first now. If we land on heads, we just accomplished a task with the odds of 1 out of 2. Now we have to draw that seven of diamonds. We should win that once out of every 52 games. But remember, the coin only wins half the time. So to get the theoretical possibility, we take the heads and the tails on the coin. That's two different instances, and we have 52 games. So if we win with the coin 52 times, we probably played about 104 games, which makes sense, because we only win about half the time. So 104 divided by 2 gives us 52. But in those 52 won games, 52 of the games that we have won, we should expect to win with the 7 of diamonds probably only once. Because that's kind of what the odds are. The odds are 1 out of 52. So our odds really translate to 1 out of 104 games should win it for us. And in both cases, we had 1 out of 104. It's a very interesting number. Let's take a look at how this relates to our actual odds. They were 1 out of 2 and 1 out of 52. And somehow that got us to 1 out of 104. Well, what if we multiply them? 1/2 times 1 out of 52 gives us 1 out of 104. 1's in the numerators multiplied to the 1, and the 2 times 52 gives us 104. So the trick was we multiplied. By multiplying our fractions together, they gave us odds as 1 out of 104. And it pretty much makes sense, because if you look at 1/2 and 1 out of 52, they're both numbers that are greater than 0, but less than 1. And when you multiply a number, a positive one, by another positive number, less than 1, it always results in a smaller number. Think of any number. 100. Okay, multiply times a number between 0 and 1. Let's say times 0.2. That gives us 20. So it always gives us a smaller number in the outcome of what we needed. So our equation is the probability, that's what the P stands for with the parentheses, A and B is equal to the probability of A times the probability of B. Alright, let's take a look at it done with the equation. Probability of A and B is equal to P of A times P of B. A is the heads on the coin, B is the 7 of diamonds. So probability of A is 1/2, probability of B is 1 out of 52. So we just plug it in on the next line. P of A times P of B equals 1/2 times 1 out of 52. And the probability of A and B is equal to 1 out of 104. Alright, so this next piece, I would like you to pause the video after I'm done talking and try the following problems. The first one, flipping 2 coins and both land on heads. So think about it. Think about the odds. How will they be multiplied? The second one I'd like you to take a look at is rolling a 6-sided die and landing on a 5. And then flip a coin and land on the heads. Now remember, the 6-sided die, it's not as crazy complicated as a deck of cards, because there's only 6 sides to it, but it's a little bit more complicated than a coin. So we'll come back to this once you're done, and you can check your answers. We'll go over it. Pause the video now. Alright, so let's take a look at our answers. So for number 1, 2 coins, they each had a probability of 1 out of 2, or 1/2. So we would just take 1/2 times another 1/2, and it gives us 1/4. And we should expect that to happen 1 out of 4 times. If you're having difficulty with it, try drawing out a chart. Try writing out every single combination of flipping the 2 coins. You're going to have heads and heads, tails and tails, heads and tails, and tails and heads. Now we both wanted to land up on heads. That's only one possibility out of the 4 there, so it translates to 1/4. So every 4 times we flip both coins, we should probably expect to get heads and heads. Alright. Number 2, the 6-sided die had a probability of 1 out of 6, and the coin had a probability of 1 out of 2. So we just multiply them together, just like we did before. 1 out of 6 times 1 out of 2 equals 1 out of 12. And that's pretty much what we should expect to happen. 1 out of every 12 times of rolling a die and flipping a coin, they'll probably both land in the outcomes that we desired. Alright, so that's your first part. Hopefully everything went smooth. If not, rewind the video and try it again, because the next stuff we're going to look at is a little bit more complicated. Alright, we are going to stop here, and there will be a secondary video that you need to watch. It'll be labeled Part 2, so pay attention for that.